Now we want to talk about the Witt ring of a field F. This is defined as a set to be the set of similarity classes of regular quadratic F spaces. You must have a few questions here. So first of all, what are these similarity classes? How do we define a similarity? Second, how do we know that this is a set? And thirdly, what's the group and ring operation? So let's answer this one by one. Let's first define similarity. Now remember that every regular F space has a Witt decomposition. It can be written as this decomposition of hyperbolic planes and then direct sum perped with an anisotropic part. This part is a hyperbolic space. Hyperbolic space is just a perp of hyperbolic planes. So we'll say two regular quadratic F spaces are similar if their anisotropic part are isometric. And we'll denote the similarity class by this. Observe that V must be similar to VA, its anisotropic part. So another way we can describe this Witt ring is that it's gonna be as a set, the set of isometric classes VA, where VA are anisotropic F spaces. So why is this a set? Well, isometric classes of quadratic F spaces are in bijection with the set of congruence classes of symmetric F matrices, and congruence is an equivalence relation, right, on the set of symmetric matrices, so that's a set. Now we will define the addition and multiplication operations. So first we define the addition operation on this set as follows. This turns out to give the set the structure of an abelian group. The identity is just the class of hyperbolic space, any hyperbolic space, because the anisotropic part of this is just 0. The inverse of any class of a space V is just a scale space, which we'll define now. So this scale space is as a set as a quadratic module, and the underlying module is V, but the bilinear form is going to be negative of the bilinear form on V. So the claim is, so why is this an inverse? The claim is that this is always hyperbolic. And why is that? Well, observe that if we have any vector x in V, right, with the norm alpha, then correspondingly in this scale space, I also have the vector x, but its norm here it's gonna be minus alpha. So if we can decompose this sum into module of this form, right? And we already shown before that module of this and note that this x and this I should call it x prime, they are orthogonal, right? So we can decompose it into module of this form, and previously we have shown that this module is isotropic and isometric to the hyperbolic space. So this just breaks down into a direct sum of hyperbolic spaces that are orthogonal to each other, so it's hyperbolic. Now we will define multiplication.